Back in 2017, I came out with the original version of my 2x72 tilting belt grinder. This wasn't the first belt grinder to serve as both a vertical and horizontal grinder, but most of the others out there, the horizontal mode feels like an afterthought. I designed mine with the same amount of effort put into the horizontal mode as I did the vertical mode. It's designed to be equally both. And over the past 4 years, that became a very popular design. Thousands of people from around the world have built that. And with a very popular design, I get a lot of feedback. So I've received so many emails from people telling me what they would like changed, what functionality they want, what part of it they struggled building, etc. And so I designed a new one that's easier to build, fixes the problems with the old one, and adds some functionality. There aren't any big revolutionary changes with this design, but almost every part of it has been improved in some small way. And since I've been selling these all over the world, I went ahead and designed a metric version as well. And the metric version is not just converted to metric from the imperial version, it's actually designed from the ground up to be metric. Because making it out of metric materials, all of the clearances come out just a little different and stuff. So I had to design that completely from scratch to be metric. So right now, in the description, you can find plans for a metric version and an imperial version of this new Gen 2 design. So let me go ahead and take you around this design and show you what's changed about it. I think the first thing we have to talk about is the tilt, since that's kind of the headline feature of this belt grinder. The hinge axis on this belt grinder is in line with the exact center of the attachment. And the reason that's important is it allows you to use the same table for both orientations and leave the table in place, which is why the table doesn't tilt with the belt grinder. All of the tables have this 1.5" post on them, which makes them indexable. You can put them in any of the 4 orientations. Also, this post is a vertical slide, which allows you to adjust the height of the table without changing anything else. This height adjustment is really important when you're using the grinder in horizontal mode, because you need to be able to adjust where your workpiece is contacting the belt so that you wear out the surface of the belt evenly. On many other grinders, if you adjust the height of the table, you lose your angle setting. But on here, that's separate. Position this way is also separate. Something else that's improved with this new grinder is that the table actually fits under the platen. This is surprisingly useful for larger items. The platen attachment on my old grinder was off-center and did not allow you to slide the table under like this. So I have plans for 2 different tables. This is the adjustable angle table. It can go anywhere from 0 to 45 degrees. And this is the fixed table. This table is welded solid at 90 degrees, which I personally like because you can't knock it out of square. You never have to worry about it. Did I set it to a 1 degree angle? No, it's square, it always is. And again, being able to slide this under the platen can be nice. Since this table doesn't tilt, it can have a notch in it. And this is an extremely useful bit of support. For anything that has an interior curve, you need that support around the back side of the belt. The other thing to point out is that there's nothing on the sides of this platen. The belt is the widest thing here. So you can grind up against the side of something on both sides. Something else that's new with this design, I don't know how useful this is, but the table holder now lines up with the belt in both directions. That just seemed like the right thing to do. And of course, the table holder can just be removed altogether if you want to do freehand work. I'm currently offering plans for this platen attachment, this contact wheel attachment, which can take a 10, 8, or 6-inch contact wheel, and this small wheel attachment, which is just massively simpler to make than the old one. I've reduced the number of parts to about half, and I've also made it so that the deflector wheel can be left in place all the time. And of course, like the platen attachment, both the contact wheel and small wheel attachments are centered on the hinge, so they tilt in place. We really have to talk about this new tensioner, because this is really simplified from the original version, and it uses a normal spring that you can buy at a hardware store, whereas the old one took a custom-made torsion spring, which was ridiculous. Very bad design. Also, the tracking on this one is tilted to an angle, which makes it much more responsive. So you now have more range of tracking, so you can track the belt farther off center. It takes only a small twist on this knob to make quite a bit of tracking difference. And also I've reduced the part count, again making it a bit simpler to make. It turns out making this use a normal spring instead of a torsion spring was a lot more difficult than you would expect, because this entire tensioner has to clear the base frame tube when it's tilted. The solution basically was to move this hinge forward. So the hinge used to be right here, and I've moved it forward about 4 inches, and also moved the tracking wheel forward several inches. And that allowed me to put the spring back here. You'll notice the legs on Gen 2 are much longer than they were on the original. That's mostly so that the motor will clear when it's tilted, but also since the platen is now centered on the hinge, that means this bottom wheel is lower, so it needed longer legs to clear this belt. Probably the single biggest change on this design is this platen attachment. And it is so much better than the original. The original one had the platen spine, this vertical part, attached to a tube that slipped over this bar, and that allowed it to have a little bit of adjustment front to back so you could square it. I've realized that you don't need much adjustment that way, because you can put a square on this to this when you're welding it and get it really, really close. And then the final squaring is done just by filing the contact points where the platen itself contacts this. This makes it much easier to build, and it's more reliable. It's less likely to be knocked out of square. Also, these little ears that mount the wheels were probably about the most troublesome part of the original belt grinder, because welding them on, they would always tend to warp and throw the tracking off. I've redesigned that so it's just kind of a sandwich that you clamp together and weld, and there's basically no way you can do it wrong. I've built 2 of these now, and they have tracked absolutely perfect on the first try, which is something I definitely couldn't say of my original. So this platen surface is just held on by these bolts that are welded to the surface, and then a nut on the back side. This just holds it back against this frame. And then there are some little pieces of flat bar right in here. There are 2 on the bottom and 1 on the top. That gives it 3 points of contact. So you can file these flat bars down if you need to tweak the square. Also, since there are 2 points of contact on the bottom, this means you can adjust the squareness this way, which is necessary when it's tilted sideways to make sure that you're square to the table this way. On the old one, there was no way to adjust this. It only takes a few minutes to weld this attachment together once you've cut the parts for it. So this is much, much simpler to build than the original, and it's much stronger, and it's a lot harder to mess up. It makes the old platen attachment just look like a terrible design. You'll also notice that the locking handle is now mounted on a 45-degree angle, pressing the bar into the corner of this tube. The old one had the locking handle right here in the side. So this is a lot more accurate, or a lot more repeatable. This table holder is pretty much unchanged compared to the original. And this adjustable angle table is completely unchanged from the old design. So this is backward compatible. It works with both. The bottom of this has been specifically designed to nest perfectly with the top of this tube. It's kind of hard to show, but this allows this table to drop as low as possible. The fixed table is designed with this support structure underneath, which is not only there for extra strength, it's also there so that the table surface can be just tack welded on, which makes sure that it doesn't warp when you weld it. That was a problem I had on the original one. There are also some changes that I've made to these attachments to make them better, but I've made dedicated videos about each of these, so I won't go into those here. I'll leave links in the description to those videos. A few other minor changes. You'll notice I used these adjustable locking handles. These are from McMaster Car. You can pull them out to reposition them. Also, I'm using square tube for the legs and for this tensioner post, as well as half of a square tube for the motor mount. And I've made these rounded instead of just a 45, which all of these changes just make it look so much more refined. So on the original grinder, the main power unit and table holder and stuff had, I think, 13 tapped holes, 3 different sizes. On this one, there are only 6 tapped holes, and they're all the same size, plus another 4 on this one. As far as power tools, you just need a drill press, a welder, and an angle grinder. I also used my portaband on this build. The portaband saves a lot of time, but is not required. I have built a Gen 2 belt grinder without one. Other than that, you just need files, a hacksaw is nice to have, and some wrenches, drill bits, that sort of thing. So I figured I'd give you a quick look at what the plans look like. So here they are. You have a shopping list, So here are some of the components I recommend, recommended sources and stuff, all of the materials you need with quantities. And then this is a cutting list, so all of the parts that you need with part numbers. A lot of these just have templates, and so you can scroll down and here we have templates. There are templates for a couple of different motor frame sizes. And then getting down into the build section, this is what most of the steps look like. I actually took some inspiration from Lego instructions here, with the addition of text, of course, for a little more clarity. And of course, if you don't want to look at it in digital format, you can just print it out. The plans are just a simple PDF, so they can be read on any device or printed. And in this case, I finished the plans before this video, so I'm actually following my own plans to build this machine in this video. So with that all out of the way, let's go ahead and get started on the build. I started the project by printing out the templates from the plans and then roughly cutting them to size. And then I could lay out my templates directly on the steel and find the layout that was the best usage of the material. I'm attaching this to the steel using this Super 77 spray adhesive. The noise this blade is making is very annoying. It has a few miles on it and is already missing a few teeth. Just ignore that. This radius in the tensioner post does not have to be cut precisely at all. It looks nice if it is, because it fits perfectly, but it's okay if it's even just a square. And here I'm just using the angle grinder to finish some of the radiuses and break the edge so it's not sharp. One of the ways that I've simplified this build is by making the main part of the grinder only have 6 tapped holes, and they're all 3/8 inch. For making this curved slot in the hinge lock, the best way I've found is drilling small pilot holes, about 80 thousandths of an inch, and those will guide a larger drill so that you can make these overlapping holes. It would not be possible to make these holes overlap like this if I didn't have pilot holes. The holes remove most of the material, but about 10 minutes with a hacksaw and a file remove the rest. I also have 2D CAD drawings available on request if you choose to have these parts CNC cut. So these are all of the parts for the belt grinder and all of its attachments, except I haven't cut down this 1.5" square bar into the tool arms yet. I need to use that to make the frame tubes, and it's better if that's full length for now. I'm using 2 layers of soda can as shims to provide a little bit of clearance in this tube. So the 1.5" square bar here is serving as a mandrel to hold these flat bars at the right spacing while I make the tube. And in the other direction, I'm using a couple lengths of 35 thousandths welding wire as the shims, since this way doesn't need to be quite as tight of tolerance. One thing that's really important here is to leave these clamps loose. They should be almost so loose that they fall off. If the clamps are tight when you weld this, then it's going to stay tight even after you take the clamps off. It's still going to be just as tight as when the clamps were on it because you welded it with the clamps in place. And we need to be able to slide this tube off of the bar after we're done welding it. So you need to start out with it loose, basically.
Pay attention to the welding sequence here. Notice how I'm welding all 4 corners at one location before I move along the length of the tube. This helps the tube to stay square.
Notice I'm able to take the clamps off without loosening them, because they were that loose to begin with. The other thing that's important is to only do the tack welds while it's on the bar. Welding it solid will only make it shrink and get tighter on the bar.
For a minute I thought I was going to be able to just slide it off, but it ended up taking a little more hammering. And now I'm just repeating those same steps to make the shorter tilting frame tube. Only this time I'm using the 35 thousandths MIG welding wire in both directions, since this one doesn't need tight tolerance in either direction. I think if I do this again, I'll use utility knife blades as the shims instead of MIG welding wire. Those are also about the right thickness. So you'll notice I'm using the same welding sequence here while welding it solid. And honestly, it's even more important here than when you're tack welding it, since it no longer has the bar to support it and keep it square. Also, I'm just putting a 3/4 inch long stitch weld every 2 inches. This is plenty. On my original grinder I welded it solid, but that was not necessary. The frame tubes are done, so next up we'll get started on making the legs and feet. These little corner braces will keep the machine from vibrating side to side. I'm setting them up on the table to make sure that the feet are coplanar, so it won't rock or anything, making sure they're the right distance apart and that they're square. I clamped up some extra scraps of flat bar to make sure that the frame tube is square to the legs and has the correct 1/8 inch offset. Here I'm working on the tilting frame tube, making a 45-degree flat on the corner that I'll weld a nut into for the locking handle. I'm using the level on this combination square head to make sure it's on a 45-degree angle. Now here comes the fun part, marrying the tilting frame tube to the base frame tube. So I'm using this flat bar as spacers and clamping it to the base frame tube, and that will hold the tilting frame tube the right distance away. I'm using a combination square to establish the correct offset in the height. And here I'm also using the combination square to check the offset at the back and then tightening the clamps.
So the hinges go on here like this. Before we weld these on, we need to somehow align them to make sure they're not crooked relative to each other, or that's going to make it bind. In my original belt grinder video, I used a piece of round bar stuck through all of them for that. I recommended against using a piece of threaded rod because threaded rod is slightly undersized. However, if we can use threaded rod for this, it's going to be way easier to get this right because we can use nuts on the threaded rod to pinch all of these layers together. So I'm going to go ahead and try threaded rod in this video. I'm not at all sure that it's going to work, but I'll try it so that you don't have to, and I'll let you know if it worked or not.
Here's why I'm worried about it. You can see how loosely these plates fit because of the undersized threaded rod. You might be able to remedy how loosely these fit by just wrapping some paper around the threaded rod to take up a little bit of that slack and keep the holes concentric. And here's why the threaded rod might be great. You see how the nuts tightening against the plates pulls them to parallel. I put a bit of folded paper 3 layers thick between the middle plates. This will provide a little bit of clearance for paint. So I put paper shims in this hinge in the middle and in this hinge in the middle. I made sure that this piece is even with this piece, so these are parallel. I also made sure that the side of this piece is parallel to this face of the tilting frame tube. And I've made sure that the threaded rod is centered on this tube, so the hinge axis will be centered side to side. And with that, we should be ready to weld this together. So something just happened when I welded here. It warped both of these hinges this way. In this case, this isn't going to be a problem. The hinge is still parallel to the tube. It's still centered. So I'm just going to continue, but this is something you might want to watch out for on yours. The threaded rod was somewhat difficult to remove, which is a bad sign because that probably means the holes aren't concentric in the plates.
I wanted to avoid welding along the outside here because that's going to tend to warp this hinge plate outward and this one outward this way, and that will just cause binding problems. A good strong weld around both ends like this is plenty. So the verdict on the threaded rod? I've changed my mind. I think threaded rod is actually the way to go. I feel like these hinge plates are better aligned on this one than they have been on my previous builds. By being able to put a nut on both sides of the hinge and press everything together, it makes sure all of the hinge plates are perfectly in line, and that ensures it won't bind. So this hinge is very stiff. Actually, that stiffness is good as long as it doesn't get too stiff to move. The stiffness means there's absolutely no play, at least. On my previous builds, they would be sort of loose on one end and tighten up toward the other end, which is sort of a bad sign because it's sort of like it's starting to bind. This one is consistently tight through its entire range of motion, so I think that's a good thing.
So the base frame is now completely done, and we just need to work on the tilting frame.
So the next step in the plans is to weld on a bolt that goes in this hole, and we're going to use that for the locking handle to lock the tilt.
This bolt gets threaded in to be just a little below flush with the front of this plate and then welded in place. This hinge plate goes between 2 other hinge plates, so the bolt can't stick out at all. I'm welding an end cap on this half of a square tube, and this will support the motor mount.
It's not that critical that this piece be attached perfectly square, but I think it'll look better if it is. Using this makes sure that this face is square to this face.
I'm checking that the motor mount plate is centered on the frame and also that the frame is square to the motor mount. I think having that end flat bar square to the frame paid off right here. That's the motor mount all done, so we can move on to making the tensioner post. These two flat bars will hold the post the correct distance from the table, and then I can use a magnet to hold this DOM square. Here again, I'm just using flat bar and clamps to get everything squared up and positioned the way I want it. And now the tilting frame is done, so we can put the two frames back together.
Next up, I'm going to start on the tensioner, which mounts right here. This part I cut as two separate pieces because that allows me to cut it out of 1.5" flat bar, which just saves quite a bit of cutting. So I need to weld this together to make one part.
The plans include a template to cut this piece as one part or two. It's your choice. This little piece of DOM gets welded onto the side of this piece, and I'm using a bolt just to keep that aligned. This little tab will hold the bolt for the tracking knob. I'm using a magnet to hold that in place. I'll hook the tension spring on part of a cut-off bolt. I'm going to weld in this 2-inch long bolt for the tracking knob to mount onto. For the next step, we need the tensioner to be locked at a 30-degree angle. Here I'm just checking to be sure the tensioner clears the base frame tube, and it does. And now I can weld in this little stopper that will keep it from ever traveling past that point. Here I'm assembling the tracking hinge. This is made from 3/4 inch OD, 3/8 inch ID DOM, although you can use 1/2 inch ID if you have a hard time finding this. The tracking hinge gets attached right here, centered on the notch in the tensioner plate.
A bolt is going to stick out from here to hold the wheel. And since this is holding the tracking wheel, it's really important that it's not crooked because that's going to throw off the belt tracking. So I'm going to sort of jig something up coming off of the frame tube down here that will hold this bolt sticking straight out.
I guess this is a concept I learned from CAD. Since all that matters about the position of this bolt is where it is relative to the frame tube, then that's what I'm referencing off of. These two washers will act as spacers to hold this tracking fork the right distance away from the piece below it. The tracking hinge fit just a bit too tight, so I'm just grinding it down a little. The tracking handle will be made by slipping a piece of 3/4 inch pipe over a 1/2 inch coupling nut. This happens to fit perfectly. The tensioner spring hooks on this bolt on the back of the tensioner and then uses an eye bolt on the bottom. This eye bolt needs to be cut down and then welded to the frame. I loosened this tensioner hinge bolt just enough that it moved freely and then attached the spring. This handle is also the most convenient thing to grab for tilting the grinder. And here, looking from the top, you can see how the tensioner is designed to clear the base frame tube for a full 30 degrees of motion. All of the cutting and welding is done for the power unit, so I'm taking it all back apart to paint it. I painted the tracking handle black to match the look of the locking handles. Everything else is painted with Duplicolor machinery gray. While I'm waiting for the 4th coat of paint to dry, I can wire up the motor and VFD. For the motor, I'm using a Leeson number 116761, and for the VFD, it's a KBAC 27D. Here's the inside of the VFD. These VFDs are pretty easy to configure just using these little jumpers and trim pots. For now I'm just wiring this up for 120 volt, but it can also be configured for 230, and I'm just using a heavy gauge extension cord as the cord. I configured this VFD to overspeed the motor, so this is only an 1800 RPM motor, but with this VFD I can use a jumper inside to double that. Actually, slightly over double that. So it runs almost 4000 RPM now. Using a low RPM motor to start with means it has better torque at low RPM.
Before I connect this wire from the VFD to the motor, I'm going to go ahead and mount the motor on the belt grinder so I know which side I want the wire to come out of.
So I'm reassembling the belt grinder, making sure to clamp it down now, since once I have the motor mounted, it's sort of awkward and it's heavy off to the side. Since this is the final assembly, I'm assembling it with washers and lock nuts this time. These hinge bolts can't be fully tightened, or they would lock the hinge solidly in place, which is why lock nuts are necessary. If the wire comes out of the front, it hits the leg here, and if it comes out of the bottom, it hits the table, so it comes out the back. I'm using the same kind of watertight strain relief here as I did on the VFD. Now plugging it in and starting it up for the first time. I used a stack of 3 washers to position the tracking wheel in the right place and then secured it with a lock nut. The wheels that I'm using here are from knifegrinderparts.com, and I actually used these for a little bit on my previous grinder, which is why they look used. And with both of the wheels mounted and everything painted, the power unit is done, and we can move on to making the Platen attachment. I'm starting by marking out the locations to drill 2 holes in this piece of square tube that I call the Platen spine. I first drilled a 3/8 inch hole through both sides, then came back and enlarged the hole on the front side to 1/2 inch. I'm marking out where these parts meet so that I can chamfer them to fill with weld. And you can see how when these parts are clamped together, there's really no way for them to be angled. Notice that I put these on the side opposite the weld in the tube, since the face of the tube with the weld isn't always flat. Here I'm checking the distance from the front face of the tube to the center of the hole to be sure it's right. Notice how I only welded these on the front and back. I did not weld on this inside corner because that would warp the ear. Now that I'm done using this square bar as a mandrel, I can cut it down and use it as the tool arm for the Platen attachment. I'm making sure these pieces are sitting flat on the surface and making sure they're square to each other and the correct offset on the bottom. I'm double checking to be sure this remains square and then finished welding it. I'm grinding a little chamfer into the corner of the tool arm for the locking handle to lock against. These tiny squares of 1/8 inch flat bar are what the platen will sit against. They're small so that you can easily grind them down to adjust the angle of the platen. And as usual, a couple of tack welds is enough, but I feel they look better if they're welded solid.
Now, if you welded this bar square to this in both axes, you shouldn't need to modify these at all. But they're there just in case you made a slight mistake, which it looks like I have. So if I stand this up on a flat surface and bring over a square that I trust, I can see it's not quite in line. So I'm gonna need to file off a little bit of these back pads to bring it back this way. So I've got it pretty much perfect in this direction. Now we can turn it sideways and check the other direction. And I can see that is a long ways off, so I'll need to remove some from the pad on this side to bring it this way.
You can see I'm focusing a little more pressure on the one pad than the other. And if you don't have a big file like this, you can use sandpaper attached to a flat surface.
Looks good. I feel like the belt tension is a little low. And I actually bought several different springs, so I'm gonna go ahead and upgrade to a bigger spring.
The bigger spring did work quite a bit better, so I've gone ahead and updated the plans to recommend the larger spring.
I think that's better.
Here you can get an idea of how responsive the tracking is. This is much better than my previous grinder. This is my Platen surface. It's just a piece of flat bar, and you can see how it hits the wheels here and here, so I need to chamfer the top and bottom edges to clear. The back of the Platen surface gets 2 holes drilled into it, not quite all the way through, and then I'm cutting off these bolts to weld into those holes. Technically, you wouldn't have to drill these holes, but they help to hold the bolts square while you weld them. And this gets installed through those holes in the platen spine and secured with nuts on the backside. I'll use lock nuts on the final assembly. With the platen attachment done, I can get started on the table holder, starting by cutting down a piece of 1.5" square bar as the tool arm. These two parts go on the sides, and all these parts need to be chamfered where they meet for welding. This was the moment where I remembered, I have a belt grinder now. This little piece of flat bar goes in the corner to connect the two sides. Wait, that's the wrong way. This thin piece will act as a filler to fill the gap in the top of the frame. And a longer piece of flat bar gets bent to fit the bottom. After tack welding, I finished welding these solid, and now I can mount this piece of flat bar as a spacer, and then this one that will hold the table holder tube. Before welding them on, I need to chamfer these parts here where they meet. It's best to make sure these parts are free of any kind of burrs or weld spatter, because they need to sit flat against each other for accuracy. The table is held in a short piece of tube made the same way as the frame tubes. This is made with the thicker 35,000th shims on both sides, since it has the locking handle in the corner and it doesn't need super tight clearance. The tube is going to mount right here, and then it needs this 45-degree locking handle in the corner, so we're going to weld in a nut there. On the tilting frame tube, I used my bandsaw to create this flat, but now that I have the belt grinder, I can do it a little faster this way. I got a little too close with the welder right here, but that's fine. I'll just run a tap through it to clean it out. Here I'm bolting the table holder tube on, and you can see how it has a little bit of adjustment front to back. This is for squaring the table. I cut some of the excess length off of this adjustable handle stud. So I have a little problem here. The end of this bolt is hitting on the side of this attachment when I slide it in. I just ground about a 1/16 inch off the end of the bolt, but you could also just put an extra washer under the head of the bolt. And now the table holder is done, so we can move on to making a fixed table.
On my original belt grinder build, I just welded this post directly onto the table, but that ended up causing the table to warp, so when it was turned over, the top of the table was convex. So instead, I'm using a structure that's welded onto the square tube, and then that gets just tack welded onto the tabletop at the ends, so those tack welds don't warp the top. But just tack welding the top onto this bar wouldn't be strong enough, so that's why this extra structure is needed. So now I'm ready to tack weld the ends of this onto the table surface. And this is our chance to get this table absolutely square to the post. So we need to make sure it's square this way, as well as this way, and this way, because we don't want this edge to meet the belt at an angle. I've just clamped this down very lightly. I don't want to put so much pressure on it that I warp this table surface with the clamps. I've put just enough pressure on it that I can move this by tapping on it and it will stay in place. So I clamped this bar onto the table post, and sighting across here, you can see that this side is a little more exposed than that side. Try to tap that into place.
And I have this table hanging off the edge of my workbench so that I can hook a square underneath it and measure over to the post to make sure it's square in those axes. It was a little bit off on this angle, so I stuck some paper shims under the frame to make it right. And I'm switching to using this red square again because I trust it more than a combination square.
I also added a couple of tack welds right here because most of the load that this table is going to see is going to be right here. So those tack welds help to transfer that load directly into the post. I think if I shorten this table post by about a ½ inch, that'll be enough that I'll be able to remove the table without having to pull the holder out.
I ended up cutting off 3/4 inch, but now it works, and I've updated the plans for that length. I wanted to actually jump on this table, but I didn't trust the clamp holding the grinder to the workbench. Now that I'm finished painting, I can reassemble everything, and this table holder tube needs to be squared. Before we can do that, we need to install the platen on the platen attachment. This piece of square bar will give us a longer reference surface to get it square, and then this piece is just a spacer to reference off of the platen attachment. And then I'm simply pressing this tight against the platen attachment and going around and tightening all of the bolts a little at a time. I'm tightening them each a little just to keep them even. I don't know if that's necessary, but it doesn't hurt.
That's it. It's done.
I have no idea how you actually do a hollow grind, but luckily this isn't a real knife. I'm just trying to demo what the machine can do.
So this is sort of what I consider the minimum configuration. You're going to want all of this stuff, and then as options you can add these things. And I plan to come out with more stuff as options in the future. But if you buy the plans, you're going to get plans for all of this as the minimum, and then these plans are offered separately as an option. So that's it from me now. I hope you enjoyed that and found it educational and interesting. Thanks for watching.